tested a few different models and we found a model that works a little bit better. We checked our ability to use the model with some converted variables. We took a couple of our numeric variables and transformed them by squaring them, and we could have done natural log or an exponent value or square root, cube root. The idea is we were trying to address skewness and kurtosis. So we found a model that we like, but what we haven't done yet is look for the correlation of the predictor variables to the other predictor variables, something we call multicollinearity. All right, so let's flip over to the reading, and you can see we've got multicollinearity. So basically features that are not too highly correlated with the other features themselves. So we can actually look at this by just creating a correlation matrix. And we've got a little beginning of one, I think, over here, but that doesn't have all of our variables in it. So I'm going to go ahead and quickly create another one. I'll go to the Data Analysis Tool Pack, choose Correlation, click OK, and then I want the values for all of my variables from Model 2. So I like Model 2 the best. We're going to go back with that. So I've got this set back up to use Model 2 all the way through charges. And I will take my output range and put it over here to the right of everything, just below these histograms. And I click OK. And I have a correlation matrix right here. I'm going to go ahead and color code it like I typically do, so I can highlight those relationships that are of interest. Okay. All right. So there I can see a number of fairly strong correlations between Northwest, Northeast, a couple of the regions. Okay, that's okay. I see a correlation between BMI and a couple of the regions, Northwest and Northeast. I see some correlations between charges and a couple of the predictor variables, but I'm mostly interested in predictor variables to other predictor variables. But looking at how they're correlated one against one other one at a time is, although it's useful, it's not giving us exactly what we want. So what we want is a way to measure how they correlate with all the other predictor variables combined. And basically we can do this by measuring their variance inflation factor, VIF. And we do that by correlating them all, correlating each variable against all the other variables. So we'll go ahead and start with that process. VIF calculations. So to do that, I'm going to build a regression. And in this case, I will build my regression with my X. My Y range will be not charges, but I'll make it BMI for this particular calculation. And then my predictor variables will be all of my other predictor variables besides BMI. I'll leave everything else the same. I'll change my output range to just below, yeah, right there, and click OK. All right, so look what's happened here. I have basically regressed all of these predictor variables against BMI. So BMI isn't down here, but it is up here in my previous model. So I got rid of the, I just deleted the cells containing model 3 data. I still have it captured up here. I wouldn't normally do that, but I just wanted to make sure we have model 2B and the VIF calculations real close to each other. So what I'm going to do is I'm going to add 2 new columns. First, I'm going to put an R squared column, and then I'm going to do a VIF score. All right, or basically the VIF, the calculation, so the factor. So we just did this for BMI. So my R square for VMI or BMI is 0.096. So I could paste that there. And then what I'll do is I'm going to run through and redo this for every single variable that I've got here. So I just did BMI. So I'm going to cut and then insert the cut cells there. Now, one of the interesting things about our data analysis tool pack, the regression tool, is that every time I run it, it remembers what I put in there the previous time. So now I'm regressing column M, which is now age, and I'm using columns F through L, which are now BMI through children, to build my regression model with. And then I've got the output range still in the same place. So I'm going to click OK. And I'm basically going to overwrite the exact same VIF regression I just built. But that's okay because I've captured the R squared for that. So now I go down here and I see my R square for, and this is where I'll need to be careful to make sure, okay, so now it's for age. Okay, now I'll do it again and I'll just kind of rotate through all these, and then I'll pause the video real fast while I do that and come back once I have calculated all of my R squareds for the various items. Okay, I've got one more rotation to make. Run my regression. Capture my R square. And put it in my table. And now just to clean things up, so I won't calculate anything for my intercept. So to clean things up, if I do this one more time after I've captured everything and put this column back, everything's right where it was before I started calculating for the VIF value. Okay, now we can start figuring out what our VIF score is. So our formula is 1 divided by 1 minus R squared. So let's run that through and see what we get. So 1 divided by, and then in parentheses, just to make sure, I'll say 1 minus my R squared score. Oops. I need to make that in the form of a formula. So equals 1 divided by 1 minus this, close my parenthesis, and that's my VIF score. And I can calculate that for all of these now. And you can see I'm at 1.0, 1.48, 1.53. 59 is my highest VIF score. So what was our basic rule? Well, if VIF is less than 3, we're fine. And then depending on how liberal we want to be, we could go all the way up to 5 or 10. So we're in good shape here. We don't have to worry about, in this insurance data set, the relationship of these variables to the other variables in the data set. So that addresses our multicollinearity concerns, and we can now move on and see what we'd like to do next.